Among the tools to extract URLs and paths from JavaScript files is Burp JS LinkFinder, which, as you can see from my search here, is available in Burp's BAP store. It is based on a script called LinkFinder, and I already have it installed. I just need to load it in. So JS LinkFinder is a passive tool that parses JavaScript files. As you can see, once you load it in, you get a custom tab, Burp JS LinkFinder, added to Burp, and it's empty right now because it hasn't been applied to any traffic. We can do that by browsing the application further, or I can trigger this manually by going over to the target sitemap and right-clicking on a target here. You'll see I have Port Swigger's Gin and Juice Shop with some traffic that has already been intercepted. I'm going to right-click on this host, and I'm going to click Passively Scan this host. That will trigger Burp's passive scanners, including extensions like Burp JS LinkFinder. And as you can see, it is populated with results. Looking closely at these, they're not very interesting. But one thing that you might want to do if they were interesting is identify, are these actual resources that are available on your target host, or are these something else entirely, right? It's not uncommon for applications to reference a large number of JavaScript files, many of which may contain content that's not relevant to what you're actually attacking. In this case, it looks like these are clearly images from our target, so let's take one of those. I'm going to copy that path here, and I'm going to go over to my repeater tab where I already have a request against Juice Shop, and I'm going to just paste this in to confirm that this image exists. A little slow, but as you can see, the image does exist. But if you have a large number of results, that's going to be a very inefficient method to determine which of these exist, right? Copying them over into repeater. So what you can do is export those. And what I'll do here is I'll export them to a file just called export.txt, very unimaginative. And I'm going to save that in my home folder. And when I open up my, or that file that we just saved here, you're going to see the first thing that I actually really don't like about this tool, and that is this absolutely brutal format that it exports, which is not great for parsing. For example, if you're using a tool like TomNomNom's Unfurl to extract components of URLs, you're going to have to pre-process this first to remove all of this additional junk information, like it gives a number, it numbers the resources that it finds. No idea why it does that. But we can process this. I do have a script to do that called JS LinkParse, which I will be uploading to GitHub, and it will be available to you through this video. So I'm going to open up a new terminal here, and the script uses Python 3. So I'm just going to run this. As you can see, I've run it already, but I need to change the name of my export. I can run it like so, and it's going to extract the full URLs as well as just the paths that were extracted from the JavaScript files, and it's going to sort them in a way that might be helpful for you. And what I would do with this is I would take all of these findings, and assuming that there are a large number of them, and then I would use a fuzzing tool, or I would use a tool like Burp Intruder to test these in an automated fashion as opposed to copying them manually into repeater. So that's what I would recommend in that route there. So as I mentioned, Burp JS LinkFinder, not a great tool because of its export format, but there are also a couple of other real flaws with the tool. It's a decent tool to have. It's a good starting point for extracting this type of information. But when we're assessing any type of tool against, identifying information from a black box system like an application, we're interested in, the rate of false positives and the rate of false negatives. Now, I haven't done a robust analysis to tell you what that rate is and what the cases are that it does find and the cases where it misses all findings. But I do have an example here where I can just show you it missing a large number of resources, and that is a testing against OWASP's Juice Shop application. So if I go back to my target sitemap and I right-click, passively scan this host, now if I go back to Burp JS LinkFinder, you'll see that it has actually identified the JavaScript files that make up this application, but it's extracted absolutely nothing from them, which is very unfortunate because I did capture this main.js file, and we can just do a very quick and easy search with a regular expression. So I've enabled regular expression searches already, and I'm just going to search for path segments here. And actually, I'm just going to use this autocomplete form that I've already done. So we're just looking for path segments of, a certain size here, or a certain minimum size. And I can scroll through this, and you can see that, this clearly, these clearly are references for a REST API that this tool did not extract, right? So it's missed some of the crucial functionality of JuShop, right? So we have some false negatives here. We're not getting the information that we'd like to get using this tool. And of course, the false positives we can see from looking at the results from the Gen and JuShop, where we have these results that are clearly not interesting and not going to be in scope for us. So as a result of this tool, not being perfect, again, it can be a useful tool to use, and I would recommend that you use it for JavaScript heavy apps, but we are going to be looking at a number of additional tools and techniques as well, because this alone does not cut it.